Okay, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here, and in this video we're going to be looking at arithmetic sequences. Now, I find that a bit of a tongue twister, so I'm just going to be referring to them as APs, also known as arithmetic progressions. Okay, so I'm going to be referring to them as APs. By the end of this lesson, you'll be able to explain what an AP is, recognize and use the recursive definition of an AP, use the formula to find the nth term of an AP, and solve various AP-related problems. So what is an AP? An AP is a list of numbers where there is a common difference between each term. The word difference will always mean some term minus the previous term. So here we've got a sequence, 3, 13, 23, 33, 43, etc. The first term is 3. Now, whenever we're talking about sequences or series, we always use the letter A to represent the first term. First letter of the alphabet, first term in the sequence. A is equal to 3. The common difference here, which we denote using the letter D, is 10. Because what we need to do is we need to take a number, we need to subtract the previous term. 13 minus 3 is 10. 23 minus 13, also 10. 33 minus 23, also 10. Okay, so you should get the point. And we can see here that they follow this pattern. The nth term is 10n minus 7. So the first term will be 10 times 1 minus 7, which is 3. The second term is 10 times 2 minus 7. The third term is 10 times 3, 30 minus 7, 23, etc. Okay, let's have a look at some examples. Find the first term, the common difference, and the nth term for 1, 5, 9, 13, etc. So we can see here that the first term makes it nice and easy. That's 1. The common difference, because it's going up, it's going to be a positive number. The common difference is just 4. Or we can just say a number minus the previous term, that's 4. 9 minus 5 is 4. 13 minus 9, that's 4. And so from here we can tell that that the nth term, maybe I'll do it like this, the nth term has to be equal to 4 times n, because the difference is 4. So that's the coefficient of n. 4 times n, and then what are we going to do to that? Well, 4 times 1 is 4, minus 3 will give us that 1. Let's see if it works for all the others. 4 times 2 is 8 minus 3, yep. 4 times 3 is 12, minus 3 is 9, good, that works. Okay, now we don't actually need to write the nth term like that, we can just write it like this as 4n minus 3, but in brackets. That is our nth term. What about question B? We know that the first term is 98. But the difference, the common difference that they all have, I know we can see here it's going down by 6. So it needs to be minus 6. Or another way to do it, 92 minus 98. Take a term, subtract the previous term. So that means because the common difference is minus 6, we're going to have minus 6 in front of the n. And then let's see what we need to do to that. So when n is 1, you have minus 6 times 1. Minus 6 times 1 is minus 6. What do we need to do to it to get 98? Well, it looks like we need to add 104. If we add 104 to it, we'll get 98. Let's just make sure it works for when n is 2. So if we have minus 6 times 2, and we add 104, yep, we get 92. So that is our nth term. Alright, let's have a look at question 2a. Test whether each sequence is an AP. Now for it to be an AP, there has to be a common difference. So let's see whether there's a common difference or not. 43, actually, you can go this way if you want. 46 to 43, that's minus 3. Minus 3, minus 3. So yes, it's an AP. Because there's a common difference of -3. What about B? Plus 3. Oh, plus 5. Plus 7 is not the same. There's no common difference. So this is not an AP. It's not an AP. Because the difference, or the differences between the terms are not common. So they're not the same. Alright, let's have a look at the recursive definition of an AP. So the nth term is equal to t sub n minus 1 plus d. Well, what does this mean? This formula states that the nth term is equal to the previous term plus the common difference. Okay, let's have a look at some examples. So let's have a look at question A. Find the first 5 terms of an AP if the first term is 17 and the common difference is 2.5. Well, if the first one is 17, we know that one. The second term, well, if the common difference is 2.5, all I'm going to do is add 2.5 to that. 19.5. Then I'm going to add 2.5 to that to give us 22, 24.5, and 27. And that's it. That's my first 5 terms. What about question B? Find the first term of an AP if the 7th term is 18 and the 8th term is 19.3. So maybe using a table of values might help us out here. So we've got n and we've got the nth term. We want the first term. 2, 3, 4, 5, 6, 7, and 8. We know that the 7th term is 18 and the 8th term is 19.3. Now, because it's an AP, the question tells us it's an AP, we know that there's a common difference. Well, what is that difference? Well, the difference is 19.3 minus 18, which is 1.3. So all we need to do now is we can subtract 1.3 each time and work our way backwards to get to the first term. So we take out 18 and minus 1.3. We'll get 16.7. Then we keep minusing 1.3, 15.4, 14.1, 12.8, 11.5, and 10.2. Now, of course, we don't want you to be doing this. This is a really long method. And so what we actually want you to do is to use a formula. And let's have a look at part 3, because part 3 tells us what the formula is. To find the nth term of an AP, this is the formula we use. T sub n is equal to a plus n minus 1d, where a is the first term, and d is the common difference. So what does this formula mean? It means if, for example, we want to work out the 86th term, if we want to work out what the 86th term is, just work out what a is plus 85 times the common difference, because we want the number n minus 1. This is n right here. 86 is n is equal to 86, so n minus 1 has to be 85. Right? Or if we have t37, it's just going to be a plus 36d. Okay, if n is 37, n minus 1 is just 36. Okay, so let's have a look at question A. Find the 20th term of the sequence 3, 10, 17, etc. Now, instead of working this out the long way and saying, 3 plus 7 is 10, plus 7 is 17, and just keep doing that, right? Instead of doing this until we get to the 20th term, what we could do, because, look at question B, it says find the 73rd term. We're not going to do that 73 times on a calculator. We might lose count. So we're just going to use the formula. The formula says that the nth term of an AP is A, actually let's do equals, A plus n minus 1d. So if we want the 20th term, what's the first term? First term is 3. N minus 1, that becomes 19. And the difference, 10 minus 3, that's 7. So we can put that in a calculator. 3 plus 19 times 7, 136. So the 20th term of that sequence is 136. Alright, what about B? Find the 73rd term of the progression 109.3, 105.6, 101.9. So let's write down the formula so we can get used to it. Tn is equal to A plus n minus 1d. We want the 73rd term. The first term is 109.3. N minus 1 is 72. And the common difference is, remember, to work out the common difference, we take 1 and we minus the one before it. So 105.6 minus the 109.3, which is negative 3.7. Okay, and that's to show, we can see that it's going down, right? The numbers keep getting smaller and smaller. So our number for our 73rd term should be very small. 109.3 plus 72 times negative 3.7, and that's negative 157.1. Okay, question C. Write the first 5 terms and calculate the 20th term of the AP with A equaling to 20 and D equaling to negative 3. So the first 5 terms, we know that the first one's 20. The common difference is minus 3. So it's going down by 3 each time. So 17, 14, 11, 8. That's our first 5 terms. Alright, we want to calculate the 20th term. So the 20th term is going to equal to A plus n minus 1 D. 20 plus 19 times minus 3, which is negative 37. Okay, so the nth term is equal to A, the first term, plus n minus 1d. We got this 19 from this minus 1. Not this one, okay, not that one, from whatever n is. Question D. Find an expression for the nth term of the AP 2, 8, 14, etc. So we know that the nth term is going to equal to the first term, which is 2, plus n minus 1 times d. Well, what's the common difference? It keeps going up by 6. Now, we don't really write our numbers at the end after the brackets. We always like to put it at the front. So I'm just going to write it at the front over here because that's what we're used to. So that is equal to 2 plus 6n minus 6. And I'll just freshen that up. 6n, 2 minus 6 is minus 4. Now, you can always check this, right? You can always check your answer. When n is 1, right? This is our first. N is 1, n is 2, n is 3. 6 times 1 is 6, minus 4 is 2. That's good. 6 times 2 is 12, minus 4 is 8. Yep. 6 times 3 is 18, 18 minus 4, yes. So we know that we did this correctly. Alright, question E. Find the formula for the nth term of the sequence 26, 35, 44, 53, etc. Alright, so the nth term is equal to A plus n minus 1 times D. Well, what's the common difference? What's happening here? It looks like we're going up by 9. Okay, or 35 minus 26, that's 9. I'm going to put it at the front. So that's 26 plus 9n minus 9, or 9n and 26 minus 9, that's equal to 17. Alright, let's have a look at question F. How many terms are there in the sequence 26, 35, 44, 53, all the way up to 917? Okay, so we know we want the nth term, which is the last term. This is technically the nth term, but we want to know what this one is. Okay, we know that this is the first term, second term, third term, fourth term, etc. But we know that this is the nth term. So we know that the nth term is A plus n minus 1d. Now what's the difference? We know it's 9. Right, it's exactly the same thing as before. But we know that the nth term, or the last term in this case, we actually know what it is. We know it's 917, so I'm going to make it equal to 917. Now I've already simplified this up here, so I'm just going to use that. I know that this is going to simplify to 9n plus 17 is equal to 917. So now this is a simple equation for us to solve. Take away 17 from both sides, divide both sides by 9, and we know that 917 is the 100th term. Therefore, how many terms are there? There must be 100 terms. That can spell sequence. Alright, G. Find the first positive number in the sequence negative 50, negative 47, negative 44, etc. So we can tell that it's getting larger, slowly approaching 0, and then will eventually become positive. But the first term is negative 50, second, negative 47, etc. So the nth term here is A plus n minus 1 D. What's the common difference? Well, it's going up by 3 each time, so I'm going to put a 3 out the front. Let's expand the brackets, 3n minus 3, and so we know that the nth term is equal to 3n minus 53. Now what do we need to do with that? Because we need to find the first positive number, we need that to be greater than 0. So I'm going to write here, positive number. 3n minus 53 has to be greater than 0. I'm going to add 53 to both sides. Divide both sides by 3, which is 17 2/3. So that means I'm looking for the 18th term. because n has to be greater than 17 and 2/3. Therefore, the 18th term is the first positive number or term in the sequence. The thing is, what is the 18th term? Well, let's put that in. The 18th term is 3 times 18 minus 53. 3 times 18 minus 53, and that's 1. Which is 1. Okay. H. The first term of an AP is 105 and the 10th term is 10. Sorry, the 10th term is 6. Find the common difference and write out the first 5 terms. So first term is 105. 10th term, so 10th term is equal to, let's do it like this. The 10th term is A plus n minus 1d, and we know that it's going to equal to 6. Okay, so this is how I've written it out. The 10th term is A plus n minus 1d, and we know that the 10th term is 6. Alright, this is just a normal equation for us to solve. Let's minus 105 from both sides. Negative 99. So d is equal to negative 11. Now that we've done that, we've worked out what the common difference is. We need to write out the first 5 terms. So the first 5 terms, T1 is going to be, well, we know that's 105. T2. Well, now we're subtracting 11 each time. 105 minus 11, 94. Minus 11, 83. 72. 61. They are our first 5 terms. Of course, if you want to write it as a sequence, you can. You can just write it as 105, 94, 83, 72, and 61. Alright, and second last question. The 5th term of an AP is 37, and the 8th term is 55. Find the common difference in the first term of the sequence. Alright, so I always like to start off with the latest term, or the, so we've got term 8. The 8th term is equal to A plus n minus 1 d, and we know that it just so happens that the 8th term is 55. The 5th term is A plus n minus 1 d, and we know that the 5th term is 37. We've now constructed simultaneous equations, and we can solve this by using elimination. So I'm going to subtract these two from each other. The a's will cancel each other out. 7d minus 4d is 3d. And 55 minus 37, and that should be 18. Now that we've done that, d has to equal to 6. Alright, we've worked out the common difference, but we need to work out the first term as well. So I'm going to sub that into any one of these two equations. I'll pick the T5. So a plus 4 lots of 6 is equal to 37. A plus 24 is 37. So therefore a has to equal to 13. And that's it. So common difference is 6 and the first term is 13. So if the question asks you to write down the nth term, We know a is 13 plus n minus 1 times d, common difference is 6. And then we can just expand it out and simplify. And that's the nth term. Alright, last question. By first finding k, find the common difference of the AP, k plus 2, 3k plus 2, 6k minus 1, then write the first 5 numbers of the AP. Okay, so we need to work out, we know that because it's an AP, they have a common difference. So if I were to do this minus this, it's going to give me the same answer as this minus this. So let's try that out. We have 3k plus 2, and we are going to minus k plus 2. Now that will give us 2k. And we'll do 6k minus 1, and we want to minus 3k plus 2. That's going to give us 3k minus 3. So now we know that these two are actually, they're equal to each other, because they are the common difference. So we've got 3k minus 3 is equal to 2k. Let's subtract 2k from both sides and add 3 as well, so that gives me k is equal to 3. Alright, now that I've done that, let's see what the first term is. If k is equal to 3, the first term will be 5. If k is equal to 3, the second term will be 3 times 3, 9 plus 2 is 11. The third term will be 6 times 3, 18 minus 1, that's 17. And good, we can see here that the common difference is 6. Alright, so therefore, common difference is equal to 6. So what's the other two numbers? Because we need to write the first 5. So I'm just going to add 6. And I'm going to add 6. So you can write this as a sequence of 5, 11, 17, 23, 29. Alright, so that's it for this video. I hope you're more familiar with APs now, that you're able to explain what an AP is, recognize and use recursive definition of an AP, and use the formula to find the nth term of an AP and solve various AP-related problems. That's it from me. Have a fantastic day, and this is Mr. Lim signing out.